All right, welcome everyone to, I guess this will be the last live stream of November, and I think I have at least one more planned for the year, and I'll get that scheduled here. I'll be a little bit later in December. The folks that, the creators, maintainers of Archemy Full Packet Capture, their software, they'll be coming on to talk about Archemy and packet capture stuff. So stay tuned for that, and then we'll be wrapping up, I guess, the live streaming year for 2024, and just continue on in. I have every intention of continuing the streams here going into 2025. So if anyone has any feedback, suggestions for guests would be really cool. Please feel free to reach out to me, drop them in the comments, or head on over to Discord, and you can just message me there. Before we get to today's guest, I just wanted to spend a couple minutes here, a couple other channel announcements. First of all, thanks to the members, the channel members, especially those of you that are early. I have a lot of ambition and plan to use the memberships to help drive channel and other activities that I can do with that, maybe some scholarship kind of stuff. I'm a long ways from that though. So but that's all part of the growth plan. So thank you for everyone for your willingness to join. I will be creating and continuing to grow the members only content area. I have some course material that I'm going to plan on move into that direction into YouTube here over the course of the next few weeks. Although I tend to get a little overly ambitious. And so I've been, for example, I have a playlist on assembly, and I've been talking about for years revamping that playlist, and I still haven't done it. So the other thing is, hopefully you've all heard, but I have been able to launch a podcast through my employer, through Google and Mandiant. It's called Behind the Binary. And the idea behind the podcast is that there's a lot of folks doing a lot of really cool things, particularly in the field of reverse engineering and things that are tangential to that. I think we do a really good job of sharing our technical expertise, but maybe not so much with the stories behind some of the tools, the people, and the events. So this is an attempt to try to capture that. And so the second episode was released last week. The first episode was released towards the end of October. You can see episode 1 here is with Nick Harbour. He was one of the original early employees at Mandiant and has long been in the field of reverse engineering and incident response, as well as involvement with practical malware analysis, one of the go-to malware analysis books, and the Flare-On Challenge. The second episode is with Victor Alvarez, who is one of the original members of VirusTotal, as well as the creator of Yara. And so he comes on, talks a little bit about Yara, the history of Yara, some of the design decisions, and then the future of Yara with Yara X. So really appreciate if you check that out. If you have any comments or feedback, please feel free to share those with me. I also appreciate subscribers and reviews if you're interested. So just to help the podcast grow and build a bigger audience. Okay, so without further ado, bring on Yesco.
Hello.
I think I got that right. Although I have a German heritage, your last name still is a little bit challenging for me. Huttenhain.
Should I say it? Huttenhain.
Yeah. Huttenhain.
Okay. So funny story. We have a daughter, and I insisted very early on that she take her mother's name because this name has brought me nothing but trouble. It's It's just Yesco. It's fine.
Yesco. Okay. Yes. I also have a near debilitating fear of names. I have this talent that I can forget someone's name instantly. I don't know.
You can, you have it on screen. You can ask me anytime.
Yeah. I don't know what happened, but somewhere along the line, the years here, it's just like someone will introduce themselves, and 2 seconds later, I'm like, oh gosh, who was that again? And then I get it in my head that I'm going to get their name wrong. I don't know. It's just this. I got this fear with names. It's just it really sucks. Well, you are here to talk about not names, but binary refinery and data transformations. So we will have a little bit of just get to know each other and the tool and a little bit about your background, and then I know we've got some demos planned. So it'll be really cool to get in and actually see the tool in action. I started looking at it because I think you tagged me in a social media post a few months back, and
yeah,
I'm like, this sounds like CyberChef for the command line. And then I went to the project page, and it's like CyberChef for the command line. Oh, awesome! This is really cool. So why don't you tell us a little bit about your background, where you currently work, and anything you're willing to share? And
yeah, first of all, thank you for having me. It's and also for, I mean, all the people watching this on YouTube, they can't tell, but I think you have an awesome setup for guests. It is very comfortable. I wanted to mention this is really cool.
Well, thank you. I appreciate that, and thanks for taking time to join. I mean,
no, sure,
these
of
are
course.
like, I'm just trying to facilitate. It's like the podcast. My goal is to talk as little as possible and just provide an opportunity for folks to come on and talk about cool things and cool projects. So
I will try to keep the bio short.
Okay.
So I was born in 1985, which and I got into computers, or I got into computers pretty early, but I was mostly into gaming. I think I got into computer security around the age of like 14, 15-ish. And then I was pretty much what you can consider the most stereotypical basement dwelling late 90s hacker that you can imagine during my teenage years. But for when it was time to go to university and grow up, I decided that I'm on the record for saying this, and I was convinced that computer security would be solved by the time I was grown up. This was not a field that you could work in as an adult, right? I mean, I saw this as something like, okay, this is new technology. Mankind is kind of struggling with it. They will figure it out eventually. But and so I decided to become a mathematician, a career mathematician. Spent 5 years studying it, spent 5 years doing my PhD, learned about how academia works, and walked out the door backwards because it was not the lifestyle that I was looking for. For those who don't know, in mathematics, at least, I don't know about all other fields, but it means that you have to travel a lot, visit a bunch of foreign universities, and I'm really more of a settling down kind of guy. Have an apartment that I can live in for more than 1 or 2 years. So I returned to, I mean, of course, throughout the years, I maintained contacts and I still knew people who had stayed in computer security. And so I still knew people who were or I knew people who were doing that professionally. And that was good because that was a way for me to kind of like turn back around and pursue that as a job. And the friends that I still had were working at CrowdStrike. The both of them who and they spoke very highly of the company. And I was like, maybe like if you ever have a job opening. I realized like during my PhD, I realized pretty early on that this would be that I would want to leave academia. So they had a year to prepare, and yeah, when it was time, there was a job opening, and I got the job. I started in 2017 as a junior malware triage analyst at CrowdStrike, which means, and I pretty much still do the same things that I did then today, which is like first assessments, right? You get a binary that nobody knows anything about, and you try to discover the most important things in the most reasonable amount of time. When like the word triage can mean different things in different contexts. So at CrowdStrike, the triage team is, I would say by now, like after all these years, are pretty mature and, dare I say, also quite good at what we do. So we also we don't just grab strings on large directories. We do end-to-end analysis of things. It's just that we are the first people to look at everything and basically sort it into buckets. Like, is it even malware? Is it interesting? Is it possibly state sponsored, or is it e-crime, or is it a red team? Like, just go through the motions, and then like if it's interesting and in an area that CrowdStrike wants to report about or wants to publish intelligence on, we move it on to whatever team is dealing with that. So anyway, this was what I started doing in 2017. We were like at that time we were just like the mission was just starting out essentially, and I have now been with the company for 7 years. That sounds about right. And I now have a much fancier title, but essentially I'm still just a code monkey who sits at his computer, reverse engineers malware, and can absolutely not believe that somebody is paying me money for doing what I did in my teenage years. I lied about one thing. It was not in the basement. I was in the attic. But yeah.
Okay.
So I feel like I'm still 16 doing what I enjoy most.
Yeah.
And
Well, very cool. I had the basement experience. Their computer was I
so
grew up
much better in the summer. So
in an
much
old
better in the summer.
yeah, I grew up in an old farmhouse, 100-year-old plus, and basement was not really finished, but it was kind of finished. And I was down there one night. I remember this still very vividly, playing Doom. And I think that was the first time that a game actually scared me a little bit, because I had all these dark corners in the background in this basement. And then you
So
had
yeah,
sort of the creepy sounds coming out of the computer. And I'm like, okay, I've had enough. I'm going upstairs.
I had a very similar experience because my first contact with the computer was so my dad's a chemist, and the first computer I played Doom on is his work computer. And so you are in an abandoned chemistry, like not abandoned, but everybody's gone home already, and so you're in an empty chemistry laboratory, like,
Yeah.
or the office adjacent to an empty chemistry laboratory, playing Doom. The walk from my dad's office to like the elevator, that was terrifying. So.
Yeah. I can relate. Yeah, it's fun, a lot of fun. But I eventually lobbied my parents to move the computer up to my room, and it eventually
So,
found its way there.
may I ask, what year were you born? I'd like to know, like, how close were you?
81.
81. Okay, so
Yeah,
just
yeah.
a tiny bit older than.
Yep, just a little bit.
Nice.
Yeah. Well, really cool. Well, if anyone has any questions, comments along the way, I'll make sure to try to bring those to Yesco's attention, and we'll answer those along the way. We'll try to keep things kind of relevant here, and if there's anything that's completely off topic, I might just save it for the end. So if
Sure.
you're really burning for an answer there, you might just have to wait. And it looks like somebody's out there working on a PhD, so good luck with that. I think the
Yes.
process is worth it. But it can be a lengthy one. And I also knew after finishing mine at a very small university that I was probably not destined for the rest of my career in academia. I'd like to go back at some point in time. I really like the teaching, I like the research, but there's something about private sector that is going to keep me here for a while. So let's talk a little bit about Binary Refinery.
Right. Yeah. So I was about to pivot to that,
Yeah.
because I'm sure you're like you put in the meeting notes to kind of like describe the genesis. So I was starting at CrowdStrike, and I was analyzing malware, and I thought to myself, some of this is really annoying. Part of the reason for that is that I am a big Windows OS fanboy, and I like to work on Windows.
Okay.
And it just didn't. But the one thing I envied about like Linux and POSIX environments is the shell experience, where you can just chain commands and do cool stuff with that. So it really just started out as me saying, okay, you know what? Why don't I just, like, the things I really need, why don't I just write a few Python scripts that can do that, and then I can kind of like just pipe them together. On like the idea was there immediately. I didn't even have to think about the base. I think it's a very natural idea when you're analyzing malware. You're in the command line, and there's a few things that you just keep doing over and over again. Like, you carve a base64 buffer from a file, and then you want to decode it with base64, and then maybe it's compressed, so you want to decompress it, and you just keep doing that over and over again. And I was just annoyed by writing a Python script that went through the motions of like opening the file and doing the things each time. And I felt like it could be so much quicker if I could chain a bunch of commands to do it.
Yep.
So I wrote a few Python scripts that I could chain together with pipes, and that was nice. And I just kept writing more of them, and at various points in the process, I thought, wouldn't it be nice if this framework could do this or could do that? And then before you know it, you are developing software.
Right.
But I did one good thing. Very, very early on, when it was really mostly a directory full of Python scripts, and CrowdStrike was still pre-IPO and a startup essentially. I went to my boss and I said, "Can I open source this?" And he was like, "Yeah." And and I was like, "This could be big." And but I think like from the outside, right, it was just a folder full of scripts, and like, of course, like you don't even have to ask me. And I think that
Right.
was a good move, because if had I, yeah, I don't know. I don't want to presume, but I think it's nice that it can be an open source tool, and that I can develop it freely. And I'm very grateful to my employer for letting me do that too. So
Yeah.
it's very nice.
Yeah. Big companies have a way of, I don't want to say it's like an intentional thing. I think it's just a
No,
byproduct of being big. They need to be very aware of their
of course.
footprint and projects. And yeah, that's great that it got out there. The Flare team where I'm at has a lot of open source tools that came as part of the Mandiant acquisition by Google, and that's now continued in I think a great legacy. So there's just so much that when you stop and take stock of how much of, like when I do, how much of my daily workflow is built on open source tools. It's like everything
Yeah,
but IDA is kind of it.
yeah,
So really cool. And I think I did find myself one day messing around in a Windows VM. So like the Flare VM is like typically the Windows environment that I set up for analysis. And I had CyberChef open, and I thought, it'd be really cool if this was just on the command line. So
nice.
yeah, I think it is a very natural extension of the workflow of what you're creating. And I don't know what it is about like PowerShell and stuff. I like PowerShell. I know it's powerful, but it just always felt clunky to me
I think
versus
I think it's made for a different use case. It's made for sysadmins. It is.
yeah.
I think it's excellent if you want to do system administration, but we're just not system administrators.
Right. Yeah.
That's
Yeah.
unfortunate, but that's the way it is.
Yeah. Um, let's see. So, how long have you been working on the project now? I suppose I could look at the GitHub and
Yeah, that's a good question. So the GitHub will tell you when it was made open source, which
right.
is not long after I started working on it. Like as I said, it was pretty early that I open sourced it. I would guess that I started somewhere in 2018. Like it was
Oh,
no
okay.
more than a year or what after I started that I had like that I decided, wow, this could work. This could be part of my workflow, or this could even be like a major part of my workflow. So 18, 19, 20, 21, 22, 23, 24, that must be 6 years or something.
Yeah. Okay.
That
That's
is a long time.
yeah.
I have not thought about that. Okay.
Yeah. Well, very cool. Okay. Well, yeah. So it's do you have any like what's the community around the project? It looks like you have a handful of contributors and
Honestly, I'm still astonished if anybody uses it at all. I feel very bad. I always have I always think my documentation is terrible, and the syntax is terrible, and nobody can really use it. But there appear to be a few people who like it and use it. And of course, I have tons of people at work who I can pester all day, and like they're like, "Hey, I wrote this script to do this stuff with this malware, and like you could do it in Binary Refinery with one line like this." And when you do that enough, you get a few people to try it out and enjoy it too eventually. But the nature of the project is just so that I don't get a lot of feedback outside of my colleagues. So to be
Mhm.
honest, I have no idea how. Like sometimes I will get positive feedback and it will make me super happy
Mhm.
because right, I'm happy if it's a good or useful tool for anyone.
Yeah.
So.
Yeah.
But to be honest, I don't exactly know how many users there are, or I don't know.
Yeah. But I mean that's a hard question to answer. I mean, you get sort of a feel, I suppose, if through contributions or issues or
Sure.
maybe people reaching out for help. I worked with a large open source project for a number of years, and that question came out like, how many folks are using this tool? And it's like, well, I don't know. We could kind of track by downloads, but there's no telemetry or anything. It's not like Windows
Right.
or any of our smart devices that are constantly reporting on us. So that's that's I know that can be challenging. Let's see, just seeing if there's any questions. There's a couple comments here about PhD work. Maybe we can get to that at the end of the at the stream here if we have
I
time.
did a
So.
PhD in pure math. I will not I'm not sure if my comments will be helpful for those doing computer security.
Yeah. Well, the question's more of a like what happens when you decide to leave academia, sort of transitioning into back to the private sector. So we can save that for the end.
Yeah.
Let's see what else. Anything else you want to discuss? Is it's not in like the Flare VM or anything like at this point in time, is it? Or like Remnux?
I don't think it is. I think it's in Remnux.
Is it in
They
Remnux?
they
Okay.
added a Docker for it,
Okay.
but I haven't checked on that in a while. If Flare wants to include it, I would not be opposed to that. I would lend great support to make that happen. Just, but you know.
Well, that you know what it's I will definitely be happy to advocate, but also as with any project, it's just an issue. Open an issue, and
Oh,
it kind of gets.
you know what? I should try that.
Yeah, I don't know if I can't speak to the actual like vetting process that goes through. Like who determines at what point does something get added to it? But I think it's usually just a community because it's very much community driven. A request from the community to add a tool. If you make a compelling case of why we don't have, the Flare VM is missing this current capability, and this helps solve XYZ, which certainly sounds like it does. It would be ready and included. And so, yeah, if I don't do it, because again, I might get off the stream and get sucked into life and forget. You could definitely just open.
I just hadn't thought about it. Sounds like a good idea.
Yeah, because I think something like that would definitely help. Just getting more eyes on the tool and the capability.
I think like if you want to, we can just start demoing it and talk through it. I was planning to do it very, very live. I have like I literally have folders with samples and nothing else, and I'll just try to wing it and show people. I'll install it and then I'll start using it so people can see it from A to Z. And you can people say this, but I also genuinely mean it. Just interrupt me at any point and we can talk about what I'm doing, or if it reminds you of a question that you wanted to ask, just that would be my suggestion. And I will be looking like this because this is the screen where I have the
where
the thing is happening.
Yeah, sounds good. Ready to bring your screen on then?
Nice.
Yeah, here we go. Okay, yeah, folks, let me know if we did a pre-flight here, and looks like fonts and everything are good. But if there's any trouble with any of the visuals here, just put a comment and let me know, and I
can zoom the font to any size.
It looks good to me though. So
okay, so it's written in Python, and even though Python has its shortcomings, I think that was a good choice. Refinery wants to be so versatile and do so many things that having a big ecosystem like Python is very, very much worth it. But I will not get too deep in. I was just explaining. It's just reminded me. So why does it say Python 3 there? It's because it's written in Python. First thing I will do is create a virtual environment, because you absolutely do want to install Binary Refinery into a virtual environment. It has, depending on the setting which you install it, it can pull in a lot of dependencies. So installing it into your global Python might not be the best idea, unless you do it in a VM. Then, then you have then it is a virtual environment in its own right, in some sense. But for this demonstration, I will just have a virtual environment right here, and then it's just installed via pip. The package is called binary-refinery, and you can install it like this. But for the demos that I do, I will need a few more dependencies than the standard dependencies. And there's a list in the README that tells you what you can put here. You can put default, then it will pull a few default dependencies, and you can put extended, then we'll pull a few more. And I want to show off today, so of course I'm pulling in more. Or you can type all. This will be terrible. This will make you watch a violent showcase of pip waging war on the forces of dependency hell, and it will be I mean, you can do that, but this will be fine. And this is still pulling in a lot of dependencies, because as I said, it tries to have a command for so many use cases. You know what? Well, I can show you the docs. So this is the website you put on screen already, and
Yep.
this is the documentation. And I recommend to look at the documentation. I put quite a bit of work into this, but will not read too much. I just wanted to show you, this is the number, this is all the commands that is in Refinery right now. So that's another reason why you probably want to install this into a virtual environment, is because it creates a huge amount of shell commands. And if it's in a virtual environment, that's a way for you to turn that on and off. And so yeah, I usually do this to see if installing it worked, and it worked. So this is the hex unit. This, I think, the first unit I ever wrote. This is why I keep testing with hex. It just does hex decoding. The idea with Binary Refinery is that you can, I don't know, 32, 33, that you can pipe anything to these things, and that doesn't work. I cannot use Linux. That's why I wrote this. So when you emit is also part of Refinery, so this is kind of confusing. But emit will just output this string in this case, and so if I emit 32, 33 and I pipe it to hex, it will hex decode it to 23. Okay. Right. I have a few. Is this right? No, this is not right. So, right. I have a few cases that I thought we could work through that will allow me to like do the whole learning curve for Binary Refinery. Start out with like the basic version, and then get progressively more advanced. And we will probably not get to case 5, I think, but I just got as many as I could, so I would not run out of material. So there's 2 files here, and I don't remember which one is which, so I'll just start with this one. EF is part of Refinery, and it stands for emit file. And this is like, you can give it any kind of file pattern, and it will output that file to stdout. And the idea is always that you move, like that you output something, like every Refinery unit reads input from standard in and writes output to standard out. And then you build like long pipelines where at the end, hopefully you have the C2 server. One unit I use a ton is peek, because it will just allow you to peek at the document very briefly. So what now happened is I wrote the contents of this file, 06 something something, that's the SHA-256 hash, to standard out, and we had a quick peek. And peek will do this thing where it shows like a bit of metadata and then give you a hex preview. And now I know it's a PDF file. And what Refinery can do for you is it can, so there's a unit called XT, which stands for extract. And I'm trying to do like the 7-zip thing here, where it can extract anything from anything. I am a far cry from 7-zip, but I mean, I've been at it 6 years apparently, so if I put in 6 more, maybe we'll get there. And XT can also extract like the contents of a PDF document, for example. And in this case, oh, no surprise, this is one of the forgotten artifacts from a time when there were still PDF exploit documents, which, to my knowledge, are extinct. Just, if I'm exaggerating, like don't please comments, don't go ballistic. So this one has JavaScript in it, I think, and I will peek it again. But this is text, and I would like peek to show me, like, try to show me the text. So I will add a little flag here, which is D for decode, and I'll add it twice so that it wraps the lines. I'm not sure if that gave us much more information. We can try this. This is it's not much more information. It looks like there is a huge string in it, and I think we just want to carve that out and decode it. I mean, it's an exploit document, and there's like huge encoded data in it. So let's get it. So this might be the unit I use most. It's the carve unit, and it does exactly what the name says. It can carve out specific formats. I think most of the time I carve base64. Sometimes I also carve int array, and in this case we will carve a string, right? Is there a string? Yeah, we'll call it a string. So
is there a comment about getting, is it Radari 2? I actually don't know how to pronounce that project. But is there any like with how you're building the command syntax, any influences from other projects, or is this all just you and how you think is a natural flow?
It's not that I'm directly influenced by Radari, but I think I don't know, but I think Radari and me, we like the people developing Radari and me, we probably come from a similar background, right? This is not my normal shell. My normal shell would be this. This is Farm Manager. And I'm doing this to be more compatible. But I come from a world where, like, I'm like an old school Windows type hacker, where you use Farm Manager and Hue. And if I had stayed in that for a little longer, probably also Radari. It's just this. To me, it feels like it's this Russian school of Windows command line foo, which is like its own. I'm speculating. I'm wildly speculating.
Okay.
But there's no direct relation between me and the Radara folks. But
Sure.
I think Radara 2 is super cool.
So yeah.
I can say that much. And yeah, the desire to have your commands be like follow the proper Huffman encoding, like be very short if you use them a lot. It's just I don't know. It's just the thing we share, I suppose.
Yeah.
All right. I will. Did that answer the question?
Yeah, I think so. Hard to tell sometimes, but the follow-up comment was, it totally makes sense. So awesome.
So to return to the example, what I want to do is I want to use this. I want to carve the single biggest string in here, which is this one. We saw it before. Carve has another nice feature. It allows you to also just decode whatever you carved if there is an appropriate decoder. In this case, it's just, right, you take the string and you resolve all the escape sequences. And what we get is this. This will look a bit better if we don't wrap lines. And so this is the exploit. It's just it's very verbose. It tells you almost exactly what it's doing. So here's the heap block and a fill block, and this is like some large number. And I think we just want to carve this like a big string again. Pretty sure, at least. Okay. And so this is called payload, and it's being unescaped. So what we want to do with this is we want to URL decode it. If I mean, I know which unit does what all the time, but if you don't, Refinery installs a command called binref that you can use to. I keep forgetting how it's used because I never use it. Right. So let's search for URL and decode, maybe. Oh, I want to search like this. So the URL unit decodes and encodes URL encoding. So this is probably what we want to use, right? We had this, and if we pipe it to URL, what comes out is this. And this looks a lot like shellcode with the E9 and then like a small integer and little endian at the beginning. And we could disassemble it or whatnot, or we can just peek at the entire buffer and see that there's like URLs in it, and then we can extract a pattern. This is the unit I use. This is the second most unit for me, and it's essentially just my personal regular expression pattern library. It will just do the thing. It would just pull out the stuff that I want to see. This is obviously very subjective, but as with all refinery units, you can read the help text and like figure out what exactly you would want to carve. But in this case, yeah, I didn't really reverse the shellcode, but I think this is like it downloads payloads and then maybe beacons to this. Also, the sample is ancient and probably does nothing anymore. But yeah, that would be example 1. It's a good point to pause briefly and see if people are. But this is the idea, right? You start with something and you keep peeking at what you got, and then you chain more things together. So it really is like CyberChef, where you just keep adding to your recipe. Just your recipe is your bash history, and keep peeking at the output and tweaking it a little bit, and then in the end, you hopefully have what you were looking for.
Yeah, very cool. Yeah, anyone have any questions so far? I got a lot of great feedback here. Looks like
thank you.
Karsten, malware analysis for hedgehogs. He sounds like he's using it.
Yes,
in a lot of his videos. So that's awesome to hear. Hey, Drew, great that you joined. So yeah, definitely. Good comments here. Started using Binary Refinery. Absolutely love it. Props to you.
Thank you. That's very kind.
Yeah.
As I said, I'm happy if it helps anyone do anything. So glad to hear it. Right, let's do the other one.
Okay.
So which one did I do? I did 06 something. So this time we do EE star. So what is this? This is a Microsoft Word document, and and because this is an old sample, as I said, I only have the samples here. But since it's old, I'm pretty sure it's old. It's probably a VBA macro document or a macro dropper or something. So I will use XT-VBA to pull out the VBA macros. Oh yeah, I remember this. Yeah, I do this. I do this example with Refinery a lot. It's kind of fun. So I won't go through the terribly written VBS too much. I'll tell you what it does. The important part is here. It will take the actual textual content of the document and replace the sequence $1 with the empty string, because this variable is not defined. And then it will write itself to a JavaScript or like, I think it's a JavaScript. We'll see. We'll see what it is, but it will write itself to disk and execute that. And you can get the contents of a document, just the textual contents, with the doc.txt unit. And I mean, we would probably have guessed, looking at this already, that there is junk, that the $1 is probably junk in here. And there is a unit to replace strings. In this case, we just want to replace $1 with the empty string. And I like convenience, so if you just don't put anything, it will replace it. The empty string is the default for this. So let's peek this just to have. Okay, it's just a huge long HTML document. I will demonstrate something just to have demonstrated it, because in demos, I always construct these long pipelines, and it's super beautiful. And at the end, I have the IOCs. But in reality, you want to dump intermediate stages to disk and inspect them, actually. And for this, there's the dump unit. So I will call this payload.html. And then you could look at it in VI. And if I could VI, then you could maybe format this and read it, and you could figure out that it is taking out this base64 buffer up here, reversing it, decoding it, reversing the result, and then executing it. And we will not do the reversing. We will just continue working with the payload. So again, we use carve because it is now. But we don't want to decode it because it has to be reversed first. So we'll just carve out the single biggest base64 buffer. reverse it. There's a unit for that. Base 64 decode it, reverse it again, and look what comes out. And that looks good. There is a PPJScript unit, which can pretty print JavaScript. And there's the downloader that will, we could even pull out that URL, which will download something from here, save it to C users public tubegirl load.jpg, and then there's some other part of the VBA that will load this as a DLL, and I think run DLL30 to it, or rec server, I don't know. So yeah, these are my intro examples where it's pretty much just exactly what I wanted when I started writing Binary Refinery. It's just a bunch of cool commands that I need all the time when like extracting payloads from malware or decoding payloads. And I think this is a pretty good showcase already. Like this is the pitch, right? This is what you want. But it can do a little more.
Okay, sure, yeah. Hey, Invoke RE, welcome.
Oh, hello.
They said they
I
started
know who
using.
that is.
I don't. I follow them though, and been thinking about in my long list of I should do this, reaching out. But so hey, yeah, if any wanted to collab on anything, let me know. But they just commenting here, they started using VStack over the weekend, and it's amazing.
Yeah, and VStack is about to get so much better.
Okay.
VStack started out as a way to get stack strings out of executables.
Okay.
And it's yeah, it is. It has grown to be. I mean, I think it's already pretty good at that, but I think it could still be a lot better. But yeah, it's I'm not sure. Maybe we will get to see it in action.
Okay, sounds cool.
I really want to do case 2, but then we won't get to see VStack. But yeah, I mean, it's still. I think this is instructive. Yeah. So, or I can show you VStack real quick. I don't think we'll have time to get to case 5 anyway.
We have another 45 minutes until piano lessons in my house start. And one thing I've learned, I did not expect this when I really wanted the kids. I'm not musical at all, and so I really wanted the kids to have some sense of musical talent. And we got a little piano, and I did not expect it to be so loud. There's no safe space in the house when they're playing piano that you don't hear the piano, which is a great thing. I love it. But,
yes, I understand.
For purposes like this, it gets a little challenging when the tutor is over teaching piano and they need to play piano. I can't mute myself enough to keep the piano out of the background.
All right. I will. Okay.
So I got 45 minutes. It's yours.
45 minutes.
Yep.
45 minutes is still enough. Then we can stay on schedule and talk about VStack later. I think. Okay. I think that's fine, because so the things I showed from case 1, they're actually examples in the README. You can sorry, I had it somewhere. Right, there we go. So when you scroll down in the refinery README, at some point when you scroll far enough, there will be a list of examples. Shows you a few things that you can do, just because having a few quick examples I think is nice. And then down here are a few malware config examples. So here's one for Remco sample, Agent Tesla. This is some XLS macro dropper. It has a PowerShell payload, and then more. And I think the ones I showed are this one and this one. So almost the bottom 2, except for this one. So these were the ones we did in case 1, and case 2 is the first. I'm not in control of my Windows. And case 2 is the first of a series of tutorials that I wrote, which hopefully are also useful. So the one we'll be doing now is the subject of the first tutorial that I have. So the tutorials are just on the GitHub repo. And the first is one about a NetWalker dropper. NetWalker is a ransomware. I don't think if it's even around anymore. And these are Jupyter notebooks that have the advantage that I can essentially I can recompile it. Oh, this looks hideous in this resolution, but it will look better when you look at it in the browser. So I can rerun them, and then the output always looks the way it would look when you actually use Refinery. And I think this is a very instructive example to talk about a feature that I added fairly early on, which is frames. So there's one sample here. I'm gonna emit, yeah, and we'll just have a look at it. And it's text, so we'll peek. Oh, this is hideous. Okay, this is better. So this is a PowerShell script, and it contains these huge arrays of hexadecimal numbers. And again, as a reverse engineer, you could go in and read the PowerShell and figure out what it does. But also, you can just carve out these buffers and look at what they are, because there's probably something interesting there. So again, we'll use carve because carve is very interesting, or interesting, useful is the word I wanted to use. But so far, I have just glossed over the fact that or over the question, what do you carve? There might be more than one base 64 buffer in the file, and I've always used this convenient S flag, which carves out just the biggest one, or the first biggest, I think, if I'm being mathematically precise, because there could be two biggest. But what do you do when there's more than one buffer, which is the case here, of course? I mean, I'm alluding to this. And what you do is you invent your own serialization format and command line syntax to deal with that. That's what you do. So again, let's remind ourselves what we're dealing with. Like this. So what we want to carve out here is an int array. And because there will be some fairly small ones, I will carve out the ones that are at least 200 characters in length. And what you can do with any refinery unit is, at the end of it, you can add a command line argument like so, which is just an open square bracket. And this, what it really means is serialize the output, right? If you produce more than one output, please output it in a serialized format that only Refinery can understand. I don't know if I what's a hex editor thing on Linux that I should have? I want to pipe it into a. Does this work? Right. I'm piping head. Right. So this is what this looks to any other program. There's some feed 1985 Coca-Cola code. I don't know. This looks like some magic number for a custom serialization format. So to any tool that is not Refinery, this just looks like weird message pack data with a weird magic number header. But if you pipe it to a Refinery unit like peek, this unit will know to deserialize the data and actually operate on each of the output chunks individually. And you have to close your brackets. Has to be correct. And this is this looks much better. So we have carved out the two int array buffers that are at least 200 characters in size, and we can work on them individually. We can work we can now do things in here that just work on each of the chunks. This is specifically useful if you write a Refinery pipeline that works on one sample, and then you can turn it into then you can mass triage a bunch of samples that you may have hunted. So, you just emit file a bunch of them and work on them inside a frame. So this is, what was it? Oh, I don't know. It will work. So, right. What do we want to do with this? We would like to decode it. So the unit for this is pack. We could also add a D here that is synonymous. So pack will just take textual representation of integers in like in a sequence, and will decode them. And I'll show both just to see that it's the same thing. So just carve out the two integer array looking buffers that are at least 200 characters in length, and then decode them. The trained reverse engineer will notice what is going on. These look to be XOR, like single XOR encoding is the most likely scenario. And one way to deal with that is the auto XOR unit, which will just, it's based on character frequency analysis, and it tries to find a XOR key that maximizes the occurrence of 0 bytes, essentially. It's essentially for decoding XOR encrypted PE files. That's what it is primarily for, and it works like a charm. So here is two evil NetWalker samples. And yeah, I just wanted to talk about frames, and that this is cool. That's really what this is all about. I get nothing else.
Yeah.
We can try to extract the config.
Boom magic.
Let's extract the config for one of them.
Okay.
So, right. So it's the 32-bit and the 64-bit version of the ransomware. They're both in there, but they have the same config. So we can also XOR it manually, like so. We know what the key is, and I think, if I remember correctly, the configuration is in a PE resource. PERC is the refinery unit for extracting PE resources, and there's a lot of refinery units that have this pattern extraction interface. Like you saw, one is XT, which will try to extract from anything, and PERC is also like a file path, like a pattern extractor for the resources. In this case, there's only one resource, so we can just type PERC, and like we could say we could write you could write a pattern here, like assuming there were more than one resource. You could type like I want the one called 0, or just 0. It tries to be clever about this, but we only have one, so we can look at that one. Yeah, I remember. So this has a prefix here, which is 5, and this is like, I mean, I know this because I've been through the tutorial so many times. So this is the length of a key that follows, and I'm pretty sure it's an RC4 key. And this allows us to showcase another feature of Refinery, which I think is very cool, or at least it's very important to me. That is variables, because so as soon as you have your own serialization format, and you're already doing that, it is very natural, or it's a very natural step to include variables, so you can attach metadata to any of the chunks in your serialized stream, and like store variables at one point in the pipeline and then reuse them later. That's very useful.
Yeah.
Here you already see that some units, they populate variables by themselves. So the PERC unit has, I don't know how helpfully, but it has added like what language this resource was, I'm sorry, at what offset it was carved, and what the original path was that it was like extracted from. And we can add another variable to this. And I want this variable to just contain this length. And this I will do like so. So I think now comes something new. I will write put k, and that means I want to create a new, like the data, like I just want to create a new variable called k that should be attached to this chunk. And what I want to put into k is the result of cut. cut 4. So this means take 4 bytes from the input and cut them out. This is a concept that I refer to as multi-bin expressions. There's always like a sequence of handlers, which are like the name of the handler followed by a colon, and then comes some expression. In this case, cut, like the thing that cut expects is like a Python slice, which is in this case from 0 to 4. And it means like when the input is coming in, the argument to this unit will be the first 4 bytes of this input, but also these first 4 bytes will be removed from the input. This is often useful when you are like, because there's so much malware that like encodes data essentially by encrypting it and putting a key at the front. This happens a lot. So right, I mean, I designed it the way I designed it because it is useful to me in practice. But then I also want K to not contain these bytes, but I want it to contain the little endian decoding of these bytes. So I want it to be just the number 5. So let's see if that worked. I'm pretty sure it did. I use it all the time. So right now we have a new variable K, and it is 5. And you can also see that the first 4 bytes were removed. We're now starting here. And then we can RC4 decode this data, and we can use the same trick. We can use cut again, and we can just cut the first K. And there you go. We can pretty print this and do like so. And this is the NetWalker config, maybe like 10 lines. That was 10 lines. I don't know. What the hell? Let's look at it. I don't know. I don't even, yeah. There you go. This is it. Right. Questions.
Very cool. Yeah.
So I think this now did introduce the 2 things that I think make it one step, or make it more like CyberChef on the command line. Like in the beginning, it was really just a collection of scripts they can chain together, and that's pretty useful. And we've seen 2 cool examples of what you can do with that. But with this, you can do much more. You can, I mean, I have a few tutorials where I get extremely showy, and I write I write very long pipelines to solve like flare-on challenges and stuff. And of course, that is, that's kind of just to show off. It's not how I use it in reality. But what you see on screen here, this is definitely something I do in reality, right? And there's no really, or at least I didn't know or couldn't come up with any other way that I could get from this, right, from this resource to a decrypted config without having intermediate variables. And intermediate variables are a very useful technique to facilitate that.
Yeah, absolutely. I'm trying to think how I would even do something like that in CyberChef. Does CyberChef has this idea of variables?
This will be confession time. I have never really used CyberChef, and I actually only learned about CyberChef like a good amount of time after having started on Refinery. So advertising this as CyberChef on the command line is something I did like that came later.
Okay. Yeah.
So I don't know. But I've seen some people write pretty impressive CyberChef recipes. So I would expect that you can do it, but I don't know how.
Yeah, I don't either. It seems like my CyberChef I use it regularly, but it's almost always such simplistic series of operations and recipes that I don't know. I kind of am in that, like, I still have this compulsion to drop artifacts and like treat them as individual things that I analyze instead of, we did this. I did a stream with the author of Malcat on earlier this fall, and he kind of showed how he never dropped
I
a lot of
watched it.
artifacts. He kind of stayed all in the tool and just sort of kept pivoting like you're doing here. And that's it seems like a really efficient way. I don't know where I got into this pattern or this habit of feeling the need to drop each kind of layer as I go and then work on that as this independent unit of thing that I have to solve and then spit that layer out and then move on to the next thing.
So to be fair, I think this is totally my workflow while analyzing. I don't think I would have analyzed this example the way I did on screen. When analyzing it. I would have dumped all the intermediate stages all the time and would have looked at them. The advantage of being able to write this is, again, that I can now, if I have something that just works generically, I can now, what I can do with Refinery, I can just do this. And now I'm doing it on every file in the directory.
Yeah.
Oh, I forgot to mention this. Yes, you can. This is technically implementing lists of lists, or a list monad that you can like flatten at any time. So you can emit every file. Now this will be done on each of the files that are currently streaming out of EF. And then once you're here, this will open a new frame, and then you will do these things for all the resources that have been moved out of each of you get the idea.
Yeah.
And once you have like a coherent, it's almost like a tiny script. And you can run this script very efficiently on a large corpus of files. And I think that's what makes it so attractive to me in triage. Because very often I start out with one file, but the first thing, and I would recommend this to anyone watching, is hunt early, hunt a lot, and hunt well. Find more samples. It will give you more context. It will tell you more about the history of what you're looking at. Hunting for related samples is one of the most important things you can do. And then when you have a corpus of samples that you think are related and you want to, then the next great thing you can do as an intelligence analyst is extract all the IOCs and put them all in some kind of tool and map them out. And this is something that I can do with Refinery very quickly. I can just, and that's what I like about it.
Now all you need to do is embed safe browsing data and block downloads in like the intermediate stages. So I'm noticing I'm running into that with CyberChef more, because it's running in the browser, like decode this payload and then I want to download it, and like this download has been blocked. I guess I got to disable protections.
That would not be a problem with Refinery. It wouldn't.
No, it wouldn't. And yeah. Okay, so he who sorts of plays an instrument says mind blown.
I'm very happy to have.
Question. I'm not sure I quite understand this from LinkedIn. What is the name of this technique? I want to do detailed research. I don't think anything
depends on what you're referring to.
Yeah, as I say, I think the overall process is just your analysis workflow of trying to unravel the oftentimes many layers or stages that malware includes.
Yeah.
Let's see. Uplifting Spirit said, I still remember these 15-line binref payloads for Flare 2023.
Yeah, I still have to do a good write-up for this year, but this year was very brutal. So
was it?
It'll take a while, yeah.
So I assume they're referring to like solutions for some of the challenges and just like really short binref commands.
I do think this is a nice way to show off if you can. If you like, because Flare-on is so representative, and if you can solve a nice Flare-on challenge with a Refinery one-liner, I try to do that as much as possible, but I also think that Flare is trying to avoid having that be possible as much as possible.
Let's see. Question from 1314 Atavio.
Yeah.
Previously, you came up with two PEs, a 32-bit and a 64-bit. How would one use a different key for each one using the XOR unit?
Right, that's a good question. So we had this, and now you want to use a different key for both of them, and you don't want to do like AutoXOR or whatever. You want to. So I can do a few hacks, and then I can answer the question a few different ways. So one thing I've already shown you is the cut handler, which will take data from the input and use it as an argument. There's an equivalent one called copy, and you could simply copy the 5th byte, because the 5th byte is encoded with the Zor key. But I suppose that's cheating. So assume you had you wanted to actually use different keys. If you want to hard code them on the command line, I suppose the best way would be to use eval, and then you can write essentially Python here. I have to peek first because I don't know. So you could Zor with eval. This is very clunky because, like, surprisingly enough, this doesn't come up a ton, but you can still do it. So this is 47 BE at index. I think this should work. Oops. I am not used to Linux, but Linux wants to be escaped all the time. Right. So this is the eval handler, and the eval handler essentially just evaluates a Python expression for you. Now, index is one of many magic variables that essentially always exist on a chunk within a frame, and it's the index, surprisingly enough. So in this case, you will pick OX47 for the chunk at index 0, and you will pick OXBE for the chunk at index 1. So I think this is pretty clunky, but honestly, most of the time, this one is much more representative, because most of the time you would carve 2 buffers, and then you need to get the key from the buffer to decode it, or you have to get the keys like earlier. You have to get them out of here, and I don't have a good example for that. But then you get into like flare-on solution territory, where you have to write really complicated pipelines that save stuff in variables and then do things with buffers first, and then restore a state from variables again. And you can't do all of that. And I would recommend, if you want to see some really complicated stuff done with Refinery, check out the tutorials on the GitHub, because they do stuff like that.
Okay.
But I hope by answering the question in several ways, that was satisfactory.
Yeah. Let's see here. Crash override. There are some CyberChef savants showing how to do for loops, which always blew my mind. Yeah, I'm sure there's always, like, almost any tool I pick, there's always some like mind-blowing use case or capability that I didn't know about.
I just recently added a loop unit, which can be used to do loops, but I don't have a good example for it, unfortunately. But it does come up. There's like, it's terrible where you have things there where, I don't know, a payload is like compressed, reversed, and then base64 encoded 20 times. Doing that with Refinery can be annoying, but in this case, you could write loop 20 and then, what did I say? Compressed, reversed, and base64 encoded, stuff like that. And you could simply write this, and it would do it. Anyway, sorry.
Okay, yeah. Yeah. I think the last time I encountered something that was like the annoying level of arbitrary rounds of encoding decryption was like some PHP web shell that I came across, and I wanted to look at the actual source. And
that is exactly what I thought of.
I think they seem to be a very common. Yeah. That's a common technique of, you know.
They like to do that.
Yeah. Let's see. Comment Discord page. So I think you're asking if anyone is interested. I do have a Discord that's geared towards those that are wanting to learn and or share their knowledge. You can find a link on my website, cyberyeti.com. So feel free to join the Discord there and drop in, say hi, and just like any good Discord, be aware of what you're asking, folks. Everyone in there is like me, just volunteering time. So please be appreciative of that. Let's see, Crash Override just really loves the tool, sounds like. So Huge fan of
Thank you.
BinRef. Always looking for more videos, which really pushes the limits of what we normally have to do with Python or Bash with this consolidated set of tools. Okay, follow up on the question here from earlier on LinkedIn. So what is the name of the technique? I'm talking about the part where you extract from the data the key required for the RC4 algorithm.
I mean, in this case, you would I knew how it worked, but you would have had to reverse engineer the malware to know to do that. So this is we had this, and then let's decrypt it real quick, and you have this. And what you would usually do, you would dump this to disk, like so. Yeah, dump can do a lot of fancy stuff as well. Like you have this string formatting syntax so that you can dump stuff from a frame conveniently. In this case, it will dump the current chunk to payload, then index dot whatever Binary Refinery thinks is a good extension for it. And then you have payload 0.dll and payload 1.dll, and you would it's a PE file. You would load it into, I don't know, your favorite reverse engineering tool, and then you would have to figure out that this thing is loading its configuration from a resource and decrypting it in that particular way. So you can't just, I may have made it sound like you can just tell how that works from the data itself. You cannot. You have to have had reversed it, which is true in this case. I did reverse it, and I knew how the config is stored.
Yeah.
But and then it is just a matter of well doing it, right? It's I mean the RC4 decryption and the taking the numbers out and the key out. That's not that much magic. I hope did that answer. I hope that answered the question.
I hope so. Yeah. Because
you're
right. There's certainly some that would be, like you just said, I mean, that would be a spot where then you would have to do the RE of the files and figure out what's going on there in order to know to do the rest of the binref commands.
And this is the case for many of the things I show here. This is why I emphasize when I do analysis, I also dump artifacts to disk all the time and look at them in IDA or in a code editor and do stuff before I go back and extend the pipeline. It's just the reason I like having the pipeline from A to Z is because then you can easily you can store you can put it in a file somewhere. If you have a new sample, you can just apply it again, or if you have many samples, you can apply to all of them. It just once you have done the analysis, it makes the part of extracting stuff so much more streamlined.
This may be a silly thought, but is there a way to take, say you have a command, one of those long commands, and save it then as a new arbitrary command name for your easy to
yeah, I've been thinking about things like that a lot. I mean,
maybe it's not necessary. I don't know. Just
what I personally do is I just have files littered around my case directory that are called something .br for Binary Refinery, and they would just contain a bunch of pipelines. That at some point in the future, I may or may not come up with ways to improve the meta aspect of using Refinery, where I mean, what I dream about is having a TUI where you have the input data and then you select units and it applies them and shows it. But I don't know. I'm not a good interface programmer, so I don't know.
Well, we have about 15 minutes. Do you want to VStack? Do you think there's time? Should we do that?
I think I can do it real quick. We'll jump to case 5 because you mentioned the Melcat stream, and I watched the Melcat stream reporting, and I thought that was a really nice sample. So I thought I'd show how to do it in Refinery. I'm not sure we can do it in 15 minutes, but we can start. So it starts out with E8, with the E8 sample, and this is an encrypted Word document. Again, if you don't know how to or Office maybe. How to do that? You just search for crypt Office, and you know that there's an Office crypt unit which can handle this for you. And after applying Office script, it's just an Excel file. Now, we could try extracting macros, but there is none. Oh, there's no. But we can. The next thing I would do is just look at. So XLXTR is for extracting contents of an Excel document. So that's what I would do next. But there's nothing either. So if both of these fail, I would just list. I would just list the contents of this Office document, and just scrolls through this a bit. And there's one thing that immediately jumps at you, that like there's a binary object embedded. So I'll try to extract that. Let's check that we're just extracting this. We are. And okay, so it's an OLE thing. And let's see what we can extract from that. Let's pull out this one. And yeah, this looks like shellcode, right? There's the damning E9, 2 numbers, 2 zeros pattern right here. And I think what we want to do is like the above part. So I think this was equation editor exploit. So I think the above part is just that's the exploit, right? It's somehow up here through bad codes, this shellcode gets triggered. So let's pull out the shellcode. The shellcode I would pull out with the REX for regular expression unit. And a little known secret about Rex is that you don't actually have to go through \hell all the time, because encoding regular expressions on the command line can be kind of terrible. For regular expressions, I have a special handler, which is Y, or Yara, and you can then write Yara-ish patterns, for example, this. So this will pull out a pattern that starts with the hex bytes E9 and then like anything. And so let's see if that seems to have worked. And so VStack is the stack string emulation unit. But what it does really is just it emulates the code, then records stuff that is written to memory. It tries to be smart about it, and releases all of that as outputs. In this case, I know that we have to adjust the weight parameter. The weight parameter is how many instructions VStack is willing to emulate while there's no data being written to memory. Because again, originally this was for, you want to point it at a function address and please pull out the stack string that is being constructed at this exact address. And then the heuristic is to just emulate instructions while stuff is being written somewhere. And then as soon as a few instructions have not written to memory, we just return. In this case, we'll have to run a little longer. And because we're not emulating a known, it's not an executable format that tells VStack what kind of code, or what kind of architecture, rather, I should say, it has to emulate. We'll have to tell it that the architecture is x32, which some people like. Maybe you should call this x86, but I don't know. This has always been more intuitive for me. And I will open a frame here to see what comes out of it. It's just, okay, so it has extracted 2 chunks of stuff written to memory. And one down here looks very interesting. So we can extract a pattern from this. And that's the download URL. So that is VStack, and that would be the first part of this example. And then since I have, I don't know, 8 more minutes or something.
Yeah, I hate to usually I just like don't bookend this. We start at a time and we go. But
we're good.
Yeah.
I think I got to show all the things I wanted to show, and yeah, thank you for letting me.
Yeah. Well, awesome. This was fantastic. I will definitely be using BinRef myself a lot more. I was aware of it, but I don't think it really just. I don't know. I've got a long list of things I want to explore, and sometimes it's hard for me to know where to even start. And so, oftentimes, like making YouTube videos is actually a way that I will do that, or live streams now,
Nice.
because it'll just finally force myself to say, okay, I want to figure out this BinRef thing. I'll make a video and share it with
Nice.
everyone.
Nice.
So yeah, really cool. I don't know if I'll have a lot of time. We had some questions earlier about the transition from like academic work and academia to private sector. If you are interested in continuing that conversation, I would suggest just going to the Discord, because we have actually a few folks in there that are pursuing doctoral degrees or have finished those recently, and I'd be happy to continue chatting with you there. Yesco, if you're not in the Discord, you're more than welcome, of course.
Yeah, I was about to say, I didn't know you had a Discord, and I will gladly join.
Yeah. It's I've been trying to grow it slow, just because I don't know. It's the first Discord that I've managed, and so I didn't want to get in over my head. We had some bot problems a few months ago that luckily there's some experienced folks in there that helped point me in the right direction to really reduce that. And and I wanted to develop in a way where like naturally I was figuring out how to structure channels and everything to facilitate those that were coming in, and not just get to be, because I'm in a few Discord servers that are really big and they're just really noisy, and it's kind of overwhelming to figure out what to do with them. But anyway, so yeah, definitely be happy to chat more there. Lance said very cool, so thanks, Lance. Let's see, you can. Lance is talking about some obfuscation and stuff, so that's really neat. Let's see, where can I find from LinkedIn? Where can I find the source of the cases we studied? Those are all in your tutorials, right?
Not all, but okay. So let me check real quick.
Let's see. I'll get the link to the tutorials up. That's just off the GitHub.
So this is in an example. This is in a tutorial. Okay, and this one, the number 5, this will be a tutorial because I mean, there's a reason the Malcat guys picked it. It's a really nice sample. It's a really nice chain where you can demonstrate a lot of cool extraction techniques. So I will write tutorials about both this and this one, which you didn't see.
Okay.
And this
Awesome.
one's boring. You don't have to see this.
Okay. And that'll be from the link I have here.
Yes,
GitHub,
exactly.
the tutorials. All right. So yeah, if you go to the GitHub page, there's a tutorials folder. That's all that I'm linking to right here. So yeah, those are very cool. Let's see. Anything else? Does anyone have any follow-up questions?
I'm very approachable.
Yeah.
If you have questions, reach out.
Yep. So that's the right channel. If you come to the Discord, want to talk education. I spent a number of years helping build some PhD programs at the university I was at, and so I've worked on a lot of dissertations, some good, some bad, and almost always my fault. So happy to pass along anything that I can there, because I really enjoyed that part of academia. And don't get me wrong, there was plenty that I loved about academia. It wasn't an easy decision to leave, but I'm also equally excited that I did, and really enjoying life outside of academia. Okay, yeah, I think that's all the questions we have. So I think we're about ready to wrap up. Yesco, thanks again for your time and coming on.
Thank you. It was fantastic.
Yeah, hopefully we could do this again. If you ever come across any sort of interesting samples you'd want to get on and live stream, now that Flare-On's over, if you wanted to do, if you're not doing them, do you have a YouTube channel? You don't?
No, I'm not very. I have a homepage where I have a section called social media, and the social is in quotes, and I think all it has is my GitHub or something. So
okay.
But I'm happy to join here.
Yeah. If you come across, in that case, if you come across anything that you wanted to to come on and share, doing a Flare-On challenge or something, that would be really awesome.
It actually sounds like a pretty good idea. I'll get back to you. It's
yeah. Okay. That'd be cool. I'm trying to do a couple live streams a month, and if I can increase the tempo, I will, because like I said, I enjoy these. You came on and did all the work. I just had to set things up and then get out of the way. So
yeah, and honestly, for me, it's not that much work because I did this already. It's just I'm
Yeah.
just reproducing things I've done before.
You've already done
So,
before. Yeah. Awesome. Okay. Well, I think with that, then, thanks everyone for joining. I really appreciate you being here. Stay tuned. Another live stream, at least one more before the year ends. That'll show up here on the channel. I'll post it on social media, and that'll be probably, I forget the date. I have a date. I just haven't gotten into schedule mode because I just got home from some travel and still getting caught up a little bit. So, yeah. With that, Yesco, I'll give you last words, and we'll end the stream.
I have nothing else to say except thank you. It was super fun, and good luck with the upcoming streams.
All right. Thank you. See y'all.